Hello, calculus. Today we are going to be starting chapter 4 and starting with the extreme values of functions. So the first thing you're looking at here is a graphic that I drew of a polynomial function with a limited domain, and you can see we have our left endpoint, our right endpoint. Those are just strictly noted as endpoints right now. Okay, we also have an absolute max up here being the highest point on our graph. You can see that in terms of the entire graph, it is the highest absolute max, also referred to sometimes as global. If you look within the red box in terms of the neighboring area, we do have the ability to call it a relative or local max. Same goes on down here for our absolute min. It is the lowest point on our graph, so it is an absolute min. But in terms of that neighboring area, it is also a relative min. Versus this guy right over here is strictly just a local minimum. It is not the highest or lowest point on our graph globally, but it is still a low point on the graph in the neighboring area, so we call it a local or relative min. Please keep in mind that global and absolute, as well as relative and local, can be used interchangeably. They are to mean the same thing. So here we go. We have 4 graphs that we're looking at right here. As we look at this graph right over here, the top left, let's discuss what does this graph have in terms of absolute extrema. Do I have any absolute mins, absolute maxes, anything like that? So this guy right here has an absolute min only. So then we're going to jump to the top right. Notice, this graph is not a all real numbers function. We have a limited domain. One endpoint is included, one endpoint is not included. In between those endpoints, I have no min or maxes. And so what we have going on here is we have an absolute max only. Okay, our endpoints can only be absolute extrema. The idea is that, yes, this point right here is at 0, 0, but that's not included on my graph. And there are infinitely many decimals that I could reach as I approach 0, but 0 is not included. So I can't say that there's an absolute min. Take a look down here at that bottom left photo. I have no absolute extrema. And then over here on our bottom right, we have an absolute max. And we also have a global min. And you're going to see me interchanging those words just to get you used to seeing both of them, using both of them, all of that. As we move through this video, pause it, stop it, wherever you need to. This is the opportunity for when you say, she moves too fast in class. Okay, now it's on the video. Pause it, copy down what you need to, rewind if you need to do that. And make sure as you go through this video that you're jotting down any notes that you have so that we can clarify when we see each other again. Okay? All right, so definition time. The extreme value theorem says if f of x is continuous on our closed interval from a to b, then you are guaranteed to have both an absolute max and an absolute minimum value. So notice you have one prerequisite. The function has to be continuous on your interval. Okay? One prerequisite. We're going to be looking at some other theorems that require more. This one's just one. It's got to be continuous. All right, next definition. Relative and local extrema. To determine where we have relative and local extrema, okay, we look for what's called critical values. So, local extrema occur when the derivative f prime is equal to 0 or undefined. Okay, equal to 0 or undefined. These are called critical values. So again, big idea. Critical values occur when your derivative is equal to 0 or undefined. This is where we have points of relative extrema. Absolute extrema can occur at critical values or endpoints. And that's what we're going to do when we start to do our handful of examples that we're going to tackle right now. So, example 1. Find all points of absolute extrema from f of x equals x cubed minus 12x on the interval from 0 to 4. Step 1. Let's talk about our prerequisite. F of x in this case is a cubic function. Are we continuous? Yes. So I'm going to write a little note that says continuous. Check. Gotta check our prerequisites. This one's just one. We will be getting into more that have more than one, but they're important. So now that we're continuous, we're going to say, all right, well, I got to find my critical values, which means I have to take a derivative. If we're trying to find our absolute extrema, we need to look at critical values and endpoints. So let's talk critical values. Take a derivative. Power rule right here. Critical values occur when our derivative is equal to 0 or undefined. I have this quadratic function now as my derivative. Is it ever undefined? No. So I'm going to make a note that just says never undefined. But now we're going to set it equal to 0 and we're going to solve. So we're going to add that 12 over, divide by 3, and take the square root. And you might say, oh, that's plus or minus. And I'm going to say, awesome, way to remember that because it's normally incredibly important. In this case, why am I not worried so much about that -2? And so you're thinking, you're maybe having a conversation with your classmate beside you, and you're saying, oh, look up here. Okay? My domain is from 0 to 4. -2 is not in that domain. So I'm going to cross that guy off right there. Okay? So I have my critical value right here of 2. I have my endpoints of 0 and 4. Now how do I determine what's my absolute max and what's my absolute min? I have to find the y values. F of 0, f of 2, and f of 4. So we plug it in. Plug in 0 back to the original problem. After you find the critical value, you are done with the derivative. For absolute extrema, we need the true y values of the original function. Plug in 0, 0, right? 0 cubed minus 12 times 0 equals 0. Now I plug in 2. 2 cubed, 8. 2 times 12, 24. 8 minus 24, -16. Plugging in 4. 4 cubed. This is when you're all probably thinking, oh, do we get a calculator? You really should know that one, guys. It's 64. 4 times 4 times 12 is 48. Got a little carried away there. So then we subtract 64 minus 48 and we have positive 16. Okay, so now we're looking here. What's your highest y value? Right there. What's your lowest y value? Right there. So we're going to write our little conclusion statement. That's going to say the point 2 comma -16 is an absolute min, and the coordinate point of 4 comma 16 is an absolute max. And you might be thinking, but what about 0? 0 right now, guys, it's just an endpoint. That's all we know about it. Okay? So, if you have any questions, like I said, jot them down. Let's move on to example 2. Here we go. Number 2. Alrighty. This one is f of x equals x cubed minus 3x squared. Alright, so here we go. We're going to tackle this guy. Again. Oh, I got to give you the interval. Yikes, I forgot the interval. Hold on. On the closed interval from -1 to 3. There we go. Same directions apply. I want you to find the absolute or global extrema. So, step 1, are we continuous? Okay, continuous. Wow. Check. It's a polynomial. We're good to go. Next step. Let's find a derivative. So take a derivative. F prime. Why is my stylus being annoying? F. Wow. Really, guys? You can't see me, and you should probably be laughing at me because this is ridiculous. But it's okay. I'm just having troubles with my stylus. All right. F prime of x equals 3x squared minus 6x. Again, critical values occur when the derivative is what? You should be saying to yourself, equal to 0 or undefined. In this case, again, we are never undefined. Okay? Never undefined. It's a quadratic. When I go to set it equal to 0, 3x squared minus 6x equals 0. How do I solve? Well, I factor. And we love factoring. Always start with the GCF. And I need my eraser. Okay, well, there we go. Don't know what I just did, but hopefully it went away on your screen. X minus 2 equals 0. So I get that x equals 0 and 2. Now notice, in this case, they are both within our interval from -1 to 3. So then I want to say, all right, I got my critical values right here, okay, of 0 and 2. I now need to find f of -1. F of 0, F of 2, and F of 3. Okay? Plug -1 into our original function. We're now done with the derivative. All right, so we plug in -1 here, and we get -4. We plug in 0, and we get 0. We plug in 2, and we get -4. We plug in 3, and we get 0. So, wait a minute. I got 2 -4s and 2 zeros. What does that mean? Do I have an absolute max? Well, I guess I do. In fact, I have 2 of them because they have the same y value. So, conclusion statement down here. -1, -4, and 2 -4 are global what? Mins. And 0, 0 and 3, 0 are global maxes. Okay. Any questions again? Jot them down. Here we go. Number 3. And number 3 is f of x equals x to the 2/3 minus 1 on -8 to 8. So again, step 1. Okay? Think about the graph of x to the 2/3 minus 1. Look at the domain provided. Can I take the cube root, remember 1/3 is a cube root, of every number between -8 and 8? Yes, so we are continuous. Feel free, because you have a video, pause this, try the problem on your own, then go back and hit play again and check your work. Okay? So here we are continuous. I got to take a derivative. So f prime equals 2/3 x to the -1/3. And this is where I'm going to say, yeah, you probably should rewrite it. I know in your chapter 3 test I told you you did not have to write it with a positive exponent. In this case, it makes it easier. When you're dealing with a fraction, whatever makes your denominator equal 0 is where you are undefined. Whatever makes your numerator equal 0 is when you're going to equal 0. So let's look at this. I will never equal 0. There's no variable in the numerator. 2 is not going to equal 0. Take a look at the bottom. 3 times the cube root of x equals 0 at x equals 0. So undefined at x equals 0. Equals 0. There we go. All right, so this is my critical value. I only have one. And it's not from where whoa, I don't know if that's happening on your screen. Sorry if it is. Okay? I don't know what my train of thought was. And let's come back to this. Oh, we only have one critical value, and it's occurred where a derivative was undefined, not equal to 0. That's different from examples 1 and 2. So again, we got to find f of -8, f of 0, f of +8. Go ahead, plug them into the original functions and see what we get. Pause the video if you want to, and then come on back, and I'm going to say, oh, hey, we got 3, -1, and 3. So then you're going to say, okay, I have 2 absolute max, and they occur at -8, 3, and +8, 3. And then I have an absolute min at 0, -1. So all of our critical values and endpoints are used in this function. All right, let's go uno más right here. Sorry if you could hear my notebook switching. The weird thing with these videos is you hear all sorts of random noises. Like you might hear my husband cheering upstairs as he watches the World Series, or my dog running around. That's going to bother me this entire time. I've been writing it in blue, and now it switches to red. You're learning weird quirks about your teacher, but that's okay. And f of x equals x over x minus 2 on the interval from 3 to 5. All right, now let's switch to red. Okay, go ahead, pause the video, try it. See what you can come up with, and think about some things that are happening because our function is a rational function to start with. Okay? All right, so let's talk about this now. Hopefully you're back, you tried it. Here we go. Notice the domain of our function right here. I'm undefined at 2. That's not in our domain. That's totally okay. We are, in fact, still continuous. Okay? Looking specifically at the interval given to you. So now we're going to take the derivative. Hopefully you use the quotient rule, and you went low d high minus high d low all over low low, and you get -2 over x minus 2 quantity squared. All right, again, taking a look here, this is never going to equal 0. I'm undefined at x equals 2, but not in our domain. That's not in our domain. So really, I have no critical values. And that's okay. That just means it has to be one of our endpoints. So I'm going to go with f of 3 and f of 5, because one's got to be a min and got to be a max. Because the extreme value theorem says if we're continuous on closed AB, then we are guaranteed an absolute min and an absolute max. So let's find it. Plug in 3. 3 over 3 minus 2 is 3 over 1, also known as 3. And 5 over 5 minus 2 is 5/3. So we have 3 comma 3 is a global what? And this is when you're probably talking out loud and you're going to say max. And 5 comma 5/3 is a global min. All right. So, again, if you have any questions, we'll go over them next time I see you. Feel free to come in before class if you need to. One homework assignment that you're going to have from these videos is going to be on page 193 and 194. You're going to do 2 through 18 even. All right, guys, have a good one, and I will see you next time.